Have a very good morning. Before we start to discuss today's course, I want to discuss a little bit of the assignments last week. So those are my brief comments to your assignments. One, right? So I told you to discuss in your group and propose a topic for your project, probably, right? So here is how you wrote. So I marked that in yellow color because those the topics that I think that is feasible, right? Good one is a campus bicycle rental system. I just said that's feasible, but here the comment is probably it's not feasible for a smaller project, all right? But if you wanted to implement this by simulations, it's fine, but I don't think you can do that because you need hardware, all right? And it's a lot of things. So if you wanted to present this by simulation and it's feasible, so I think the topic is interesting. And even though, I know some students already done similar system like this, bicycle rental system, but I think it's quite practical, right? And I give this a good grades because even though it is hard to implement this, but it is allowable, to do this by simulation. Okay, so campus bicycle rental system. Fine. The second, the group 2 is home or self-care services for elderly. There are many commercialized products, so I don't encourage you to do this because you can find lots of ads, right? And also you need to have wearable devices for this project. I don't encourage to do this. It's already commercialized. You can find lots of products. Good 3 is a good topic. I don't understand the title, right? The name is StoreX. But I think that's the best one. Good topic with thoughtful reasons, right? And good 4, travel journal. Well, unclear description. No, that's pretty bad. Good 5, good map system. You can find lots of products. So it's already commercialized. I don't encourage you to do this. Group 6, instant patient bed system. Well, I think that's a good idea, but it's not feasible for a smaller project. That's different from group 1 because group 1 you can simulate that. But group 5, no, you need to cooperate with hospital. So I don't think it's feasible. Group 7, Pet Smart assistance. I think it's feasible and practical. Okay. Group 8, care bracelets. Also, you can find lots of commercialized products. I don't encourage you to do this. Right. Group 9, parking apartments. I think it's feasible. But the description is not enough, to to make it useful. All right. So I think that idea is feasible and pretty good, but should rewrite or add more useful, probably not more, but useful functions. So parking apartments. The last one, online learning platform. You can find lots of products already commercialized, so I don't encourage you to do so. I mark 14, in white, in yellow color. It means that you can choose any team. You can choose any of them, become your project, but rewrite. All right, you got to rewrite it because it's not complete. So if you wanted to, if you think that well, you wanted to do campus bicycle rental system, you know that you need to simulate that because it's not feasible, to do this, to implement that for a small project. So any one of the 4 that you can choose. All right. So I think, well, students have pretty good idea. So I think that it could be a good way, to adopt, the good ones as your project. And if your team, like group 1, you think says, oh, yeah, after thinking about that and you decide to change, then you can choose one of the other 3, right? So you also can change your topic. So those other topics, I think that's, you can do that. So, feasible, even though that's the group 1, but you can simulate that. Let's see. The other class, you can choose. You also can choose one of them, right? Instead of your class. Right. There are 8 groups, and I chose 3. Dynamic pedestrians, behavior detection system. Well, I think that's feasible, but unfortunately, their description is unclear. So you can rewrite it, and I think it's a good topic. All right. So even though there's unclear descriptions of the function, but I think it's feasible. If you are interested, then you can choose this. And the third one is pet tracking platform. I think that's a nice idea, right? So you still can choose that. And group 6, they didn't provide a title, but now they do have, they add that, right? It's also pretty good. I can keep the 95 because lacks of a topic name, so I take out 10 points. I think that's a good description. All right. You wanted to know what their topic is, then you can download, right, from class, right? So you can choose one of the 7 project as your project, but you got to rewrite it because it's not complete, right? And you can discuss it. So even you choose the same topic, but it could be different from other team. So yeah, that is the evaluation, right, that I gave. Any question? Do you? And you should decide one of the topic. I think probably before tomorrow, right? Tomorrow you got to decide it and tell your decision to TA. Before doing that, because you got to read the description, right? So you can download that from the Chan class. Is there any question? Okay. Bye. 我教一下中文。你们的作业那我给了简短的评语那我刚刚有这个 highlights 用黄色的用黄色，一共有7组。那这7组呢，无论你是不是7组里头的一组，如果你要 change 你的 topic 是 OK 的明天以前你们要决定要哪一个 topic， 每一个 team 你可以从这7组里头，我原来想用我的但是我觉得你们思考过了，而且有的也真的是不错那因此我就 suggest 你们可以选择其中的一组，但是当你读了就是你去读这7组的，可以 download 他们的 description， 那你们在明天以前就要决定要用哪一个 topic 当你的 final project 所以你们要讨论一下。我说，因为这是1个礼拜的时间，你们你不到1个礼拜就提出来的，那很多是不是很清楚的？有的 topic 我觉得 feasible 但是叙述就不是很清楚。那也许过了1个礼拜，你可以更清楚的。那其他的组别呢，你可以根据这个 topic 呢，你们去思考应该要有什么的功能。因此呢 ，even 你们选择是同一个 topic， 可能你们的那个 function 呢会有差异这个是考虑一下所以你应该不会完全依照他们的 description 就当做你的 project 因为在我们的 teamwork 第一题就要问你这个 project 这个 project 你要叙述一下，所以你们必须要讨论，你才能够完成第一题，就是我们 teamwork 第一题。那你们在明天就要决定你的 topic， 然后讨论一下我们的 teamwork one 就是在根据你所选择的这个 topic 来做的。Okay, let's proceed to the methodology. Last week we discussed methodology, right? So the methodology consists of 3 categories. They are structured, rapid application, development, and agile, right? So we also compare each of them, right? So you can choose an appropriate methodology or cooperate with other methodology to do your project, right? So you wanted to design a system. You need to know that which methodology will be suitable, for you, right? And today, the methodology, is a supplement, right? So we will describe the methodology that you will see the spiral, right? So see spiral and from different thinking, prototyping, and also, well, I'll give you a lot of supplements of stream programming, Scrum. You can read it by yourself. Also, well, we will describe a little bit the rope, right? Finally, for this chapter, the process, then we will discuss data and process. So another chapter not included in the two textbook is Sherry, right? Sherry, the textbook Sherry is a traditional data flow diagram, ERD, right? Okay. So no matter what system you're going to design, you will encounter the problems. Some of that could be easy to solve. No, some could be difficult. All right, not one system, encounter all the problems are difficult. Some of that could be easier, or some of that, be difficult. Right. So in this chapter, I use two terms, words, to describe the complexity of the problem. So one is TAM problem. The other is wicked problem. So usually a project or a system will have easier and difficult problem, not just one type. All right, so let's discuss TAM. Okay, TAM is a soft, the meanings of the TAM. Okay, we can say that, well, it's so TAM. A sheep, it's TAM, all right? It's a good temper, TAM problem. So that is TAM problem, so imply the problem, we can sub it as correct or incorrect. So like you wanted to calculate, right? So the inputs to any situation, we got the same outputs. The result will be the same. If the result is different, then that's wrong, right? So if you can understand that, or you conduct testing and it's wrong because the result is different, that's wrong. You can say that's wrong. All right, that's a TAM problem, right? TAM problem, well, usually that's, our computer, are good at calculating those kinds of problems. So it says TAM problem. So if your solution can tell right or wrong, then it's TAM problem. Then it's right, okay, stop, because pass, right? It's that they are stopping rule, just correct and that's correct. You cannot do it better, it's just correct or incorrect. It is a scientific process, right? So part of your problem could be TAM problem, and the other uh, wicked, wicked, wicked problem. So if that is a wicked problem, then well, it's hard to say best. For now, it could be best, but whenever a new technology or new algorithm, you can sub it in different way and interpret it with a better, you know, result. Then it's a wicked problem because you have a lot of room to improve it. No stopping rule. All right. So enough is enough, like that. Wicked problem. So a lot of problem that's wanted to improve, right? Improve. So you wanted to enhance the performance, make it quicker, but always has room to improve it. So it's a wicked problem. Or well, that's better, or for now, or for this situation. For this situation, yeah. But when you change it to other situation, probably not. It's a wicked problem. So one solution does not fit all situation. It's a wicked problem, right? So always has a room. So that's interesting because, well, a wicked problem when you solve it, then you cannot say that's a final, right? It always has room to improve it as a wicked problem. All right, that's the process, a political process. So it's not scientific. Right? A 10 problem, you solve it, but when combined with a wicked problem, that probably is not good, right? So because for different situation, you need to do it differently. So wicked problems and 10 problem. And mention this and the descriptions right. Okay. So last week, Dennis textbook gave us an definition of rapid application development. One of that is prototyping, the other is throwaway prototyping. All right, so here is a throwaway prototyping and evolutionary prototype. This is similar for throwaway prototype, but then you can see that when you refer to the table, right, comparison of the methodology, you can see almost everything, every situation, prototyping, throwaway prototyping is good, excellent, because you have enough time and budgets, right? You can learn, and you have budget to support you to do so. So that's, well, if you use throwaway prototyping, well, it's almost everything, you can do that. But here it says, no, wait a minute. Even though you can use throwaway prototyping, but it wastes time. It's a waste time. How come you can have enough time and budget to do that? Probably not, right? So don't throw away the prototype. So here, throwaway prototype says that's waste time. No. So it's better to put it as part of your system, but there's a difference between prototyping, the methodology mentioned in Dennis' textbook, and this. The Dennis tells show prototyping is not feasible, right? Because you wanted to see the result earlier, so it's prototype, and it become your system. And here it said, oh, wait a minute, why is it not that simple? Because you gotta have a lot of product, all right? So it is iterative and incremental steps, right? You always add value or scope to make the original prototype will be different from the later version and eventually become your system. So evolutionary prototype means not just one prototype, right? one prototype, it says one prototype, then it's not feasible, not, no, sorry, it's not reliable, and it's for a very simple task. But here, evolutionary prototype, not just for simple task, right? So based on previous versions of prototype, that you have room to improve it. So that's the difference descriptions of the prototype. Okay, and it's going to see. Oh well, which one? Okay, spiral. Right. This is another methodology. Right. You can see this methodology. Combine a couple. Methodology. So you can see prototype. Right. Prototype. So you see prototyping, and you also can see waterfall. All right. And a special feature of this methodology is that you got to conduct risk analysis. Well, I think that could be very important, right? Because we wanted to reduce risk. That's quite right. Reduce risk, right? If you reduce risk, then then you can enhance the quality of your design. So here mention risk analysis, right? So you got to see that what risk that you have, and try to tackle the risk, right? So here, if you wanted to stop the risk, examine that and to see that, do you stop the risk? If yes, then you can go to the planning analysis, design, implementation is a waterfall, right? But if not yet, so conduct prototyping, because they help you understand, right? And if your prototype works, and that's, well, that's pretty good. And iterate it, and go to add something, right? And it become evolution model. So that will combines what we just described, the evolutionary model, by using prototyping, right? So yeah, spiral process model. So you're going to see that it says not begin outside, so right. So it says begin, right. It just tell you that you need to understand your requirements, objective, of course, right, and any constraint, all right. If you have a very big constraint, it's probably not feasible, right. So last time when we talked about the deliverables of planning phase, right, and we know the deliverable will be the feasibility study report, right. So that's tell us, is this feasible from technical? Can you do it? So technical point of view, yes, we can. All right, it's technically feasible. Or what about your organization support you? It's budgets, financial feasible. So it's financially feasible, or it's operation. The user like to use that. So if that is feasible, then that means that it overcomes the issue of constraints. You have very smaller constraint, or that the problem is not this matter about that, right? So start to have that kind of thinking, right? So you kind of have a vision documents, or so that's understand that you're going to go forward, and it's fine. So the spiral process model, you got to have that in mind, and then, right, you analyze risk, right? So could have risk, even though this is feasible, right? But well, what about a risk, right? So you got to consider that, and analyze the risk and go as inside out, right? So that's spiral process. Yes, Richard?
I already know that the spiral process is try to deal with the risk, but I'm not able to because the textbook didn't give us the risk definition. So could you give us some example of how the spiral process define the risks?
Define the risk?
Yes. What is the risk definition referred to the spiral process?
Okay. So, well, it's a pretty good question. We can encounter many risks, right? So probably, well, the government might change regulation rule, all right? So because they announce something, right, and that will affect our system. So, so there could be a risk, or your professional employee, might leave, right? So then that is a risk. Or your probably authority come from your supervisor. Well, it seems not support you. For now, probably yes, but you know that, well, something, you still need to think about that, right? So there could be a risk, right? So we have a lot of risk there, and so risk analysis, you got to think that if the government changed the regulation, all right, so you need to correct the data, all right. So it's not just a change abruptly, suddenly, all right. You got to have some track, right? You understand it could change. So if it changes, can you do that? All right. Or, well, the risk, if there is a management issue, then it could be very hard to do that, even though technically that's feasible, and technically you got a group of professionals that can do it, and you have enough support, the budgets, but you know that's the user against it, right? So even though you make design, they will not cooperate with you, right? So lots of risk. So how can you solve it? All right. So you can think, so risk, it may happen or not, all right? If it is a highly, you have a high possibility that will happen, then it's a high risk, all right? If it will affect your design, it's high risk. So you can think about it from technically, from many, even you pass the feasibility, study, but it doesn't mean that you don't have risk, more or less, all right? So it's a risk analysis. Okay. Is there any question? So risk can come from everywhere, all right? You propose an idea, and you think that you can do it, but probably you overestimate it, all right? So technically, you overestimate it, then you find out, oh no, we cannot solve it, So don't overestimate it. Or your estimations of the schedule, is very optimistic. But you know that, well, your schedule will go behind the schedule. You usually are late. We know that the system, compressions always late, right? So what if you're late? You'll be punished, probably, fine. So all of that are risk. So analyze that. What are the risks that you probably cannot deal with them, right? So I think that it's quite important. Don't overestimate your ability, right? So like some student may think that, well, I can do it myself for the team project. Some students think that, oh, I can do it. Why should I cooperate with others? Probably overestimates your ability. So that's a risk analysis. Any other question? Right. So already discussed that last week for the wrap. You can see that's iteration, right? And you can see the proportions of the shadow. You can see that area. That's we said that, for example, inception, initiate your idea, all right, and even initiate your idea, you do a little bit of testing, and a little bit of implementation. So here, implementation probably not the real site, but you simulate that implementation a little bit and ask for feedback, all right? Ask for feedback, and change your design. And if you wanted to change the design, if that is not related to, got to modify your analysis, you change your design. Or you wanted to, go back to analysis, or you have more requirement. You need to correct more requirements. So you can see that inception. So every phase, right? You say the phase inception. Also, it's a lot of iteration. So iteration and go. When we go to elaboration, right? We know that it's already, based on the documentation. So this methodology needs documentation, all right? It could be a vision document. So the vision document, like a work plan, right? The vision document or vision documentation, well, list the feasibility and the scope, purpose, of course, and how to step that's all right. You have your vision towards a new system, and you conduct a lot of analysis and designs in the elaboration. Of course, you should have the documentation, the UML, right? So a lot of diagram, and probably a prototype. Construction, right? You have your working system prototype, construction, and transition to a new system. Of course, you got a new system that will be your deliverable, right? So that is the supplementary description, of the methodology. It's okay, right? So, Tony, tell us the difference between prototyping, describing Dennis' textbook, and this. Prototyping. No, evolutionary prototyping. Can say that. Okay, you don't have a name. Oh, Mort. Can we answer this? No. Who can answer? Alex. Right. Good.
The prototyping in the Dennis book is we want to know the model faster. We want to see the model in earlier. Then we going to have the every feedback we got a new version of the model. then we can provide a new one. And in this textbook, it means the prototyping is not that simple because it could be a waste of time, or something else you need to define.
Waste of time. What do you mean? Waste of time. Prototyping waste of time. Yeah, yes.
The prototyping is enough. It has enough time, but the throwaway prototyping is more feasible to the design.
Pardon me. Here, because I asked the questions about difference between prototyping and evolutionary prototyping, and you asked throwaway prototyping. Just focus on prototyping and evolutionary prototyping.
The throwaway
No,
prototyping is more like basic, but the textbook in this is in evolutional prototyping is they say it's not that simple.
So one is not that simple. Okay, elaborate that.
The evolutional prototyping it says it's a waste of time. It's not that simple.
Not sufficient. Anyone wanted to answer this? Okay, Ethan.
Evolutional prototyping is more reliable than the regular prototyping.
Okay, why?
Because evaluational prototype is an update of a throwaway prototype.
Updates of throwaway prototyping.
Yeah.
What do you mean by that?
Evolutional prototyping
Evolution.
can save more time than the or regular prototyping.
What do you mean by that? Save more time.
Maybe I'll find another answer. I'm sorry.
Yeah, and so anyone wanted to continue this description? Okay, and Sakura.
The prototyping and it is not reliable, and
It's not reliable.
yeah, and throwaway prototyping is more reliable, but you have to spend more time.
Yeah.
So, and evolution prototyping try to fix the problem of throwaway prototyping, spend more time and effort, so it spend short time.
Yeah, and evolutionary prototyping. How many prototypes you're going to have? It's only one or more. It's evolutionary prototyping. So how many prototypes you're going to expect it?
So,
Anyone wanted to describe it? Harry?
It's more prototype. It's
One prototype. Yeah, and tell us why was it
because evaluation prototype models lets the prototype even into the production system. It means you update the prototype and the prototype finally is being a system.
okay. And both for prototyping itself become the system.
Yeah.
And evolutionary also become the system.
Prototype not. Evolution prototype is only evolution prototype. I think that.
Okay. Well, based on their feedback, right, their answer, well, some points are going to mention that both for prototyping itself, right? Prototyping, Harry, prototyping is for very simple task, simple system. Prototyping.
Prototyping is simple for test. Yes. Yeah, I think.
Yeah. And evolutionary prototyping.
I think it's more complex problems, but it cuts for many prototype.
Okay. All right. So here we go. That could be a task, or could be a system. That a system or also the project that is simple one, all right? Simple one, and you wanted to see the working versions of the system. You use prototyping, right? So prototyping eventually become the system. So become the system. All right. So it's a system prototype, but it is not reliable. So there's one thing I wanted to revise your description, right? It's prototyping. Evolutionary prototyping, right, is more reliable because a number of rounds of prototyping, all right? So based on the previous versions of prototype, you add some value or expand the scope, all right? Then become the system. So both go to the system the same. But prototyping itself, that's probably, you just wanted to see the differences for simple one. But evolutionary prototyping also becomes system, but it's more complex. So the system is not that simple, right? And prototyping itself, right, says, we just wanted to see that. We know that because it doesn't matter about the system eventually. This is not for commercialize, right? We just wanted to study that. It is a system, you can see that, all right? If you're interested to use this prototype become a system, then you got to do more than that, right? Like your graduation project would not be a commercialized product, right? That's but nobody will buy that. We buy your idea, right? Buy your idea. We gotta do a lot of things. So yeah, it's also wanted to see that's a working version, but for evolutionary prototype, it says that well, you got to do that. So if you have the prototyping, for example, then it's right. It's just not reliable, but we got that, and then we refine it, all right. And we improve it and analyze the risk, and conduct more, and it become you can commercialize it, all right. So there's a difference between that, right? Jack, tell us the characteristic spiral. What makes the difference from the other methodology? Whatever. So tell us special feature of spiral methodology. It's microphone.
Spiral is like a life cycle plan. It has four level, and it will repeat like a cycle.
Mm-hmm.
It repeat. And
Mhm.
waterfall is from beginning to is what as a level, one level, and
Sequentially.
yeah,
Mhm.
start to over like that.
Mhm. And what special feature that probably we cannot see that special feature, so spiral? Anyone wanted to answer this? Special feature of spiral? This is not that difficult, I think. Oh. Okay, isn't right?
It can analyze the risk for spiral.
Okay, yeah, that's good. So last week when we described methodology, well, we don't see the focus, no. It's risk analysis, but spiral, you can see risk analysis. So I just describe that risk, right? Talk about risk. So it's quite important features of spiral, right? And West, okay, West. Can you give us an example of 10 problem? Problem. Answer that. Anyone can answer this? Raise your hand. So if you know that, raise your hand because I will choose and for TA with markets. Leo. Yeah, yeah.
10 problem can be its problem can be fixed, like program bug,
Like what?
uh, like program bug and
Bug. No bug. So the result, can we say that is correct or not correct? The result. Can we determine the results? 10 problem. What about if we wanted to have a summation, calculate that. Is the 10 problems or a wicked problem?
sorry, can you repeat again?
Calculation. Calculation. Is a 10 problem or
It's a 10 problem.
a 10 problem? And okay, yes. Shane, Shane, all right. Give us an example of the wicked problem.
For wicked problem, like on the book, it said like system analyze and design, because this situation is not it doesn't have a correct answer. You need to analyze something like market or business, politics, like that, and you need to give it a correct or maybe you need to think a best situation and how I think about it. So
Is a problem unique?
yeah, it's very unique. It's not have a
It's not a general.
general process. So
Okay, it's a unique.
yes, it is unique.
Okay, pretty good. Yeah. All right. Let's take a break.